Greetings, dear colleagues. My name is Hasan Berke Öztürk from the Kocaeli University Department of Mechatronics Engineering. Today I'd like to present you our study titled The Development of Optimal Task Allocation Algorithm for Unmanned Aerial Vehicle Swarms. So we designed an algorithm that solves the task assignment procedure for the multi-agent systems. Initially, the multi-agent systems is a branch of artificial intelligence which is highly used with a major research field called the cooperative control. Cooperative control enables agents to execute certain applications such as space-based interferometers, combat, surveillance, and reconnaissance, etc. And to enable of these approach, various cooperative control capabilities need to be satisfied, such as the flight foraging, task and role assignment, etc. So what we focused on this study was developing an optimal task and role assignment or the task allocation algorithm for the multi-agent systems. So there are certain algorithms in the literature that have been proposed for solving the task assignment problem. Namely the centralized approach and the decentralized approach, according to the allocation types. Also, another classifications can be made according to the assignment type in single robotic or single task assignments and multiple task assignments. Conventional algorithms, like the Hungarian algorithm, is a centralized approach which solves the task assignment procedure in a centralized fashion. Hungarian algorithm, or the centralized approach, assume that there is one main control center that collect each agent's information set. Agents are also the autonomous vehicles. So each agent's information set and uses it to decide on behalf of the entire fleet. So because of these main control center collects each agent's bits, we can assume that this center decides by reaching a global optimum or the optimal value. But as a major drawback of this approach, due to this single processor which the main control center has, rather than using the several processors or separate processors, by using the other agent's potential and using the power of the parallel computing, doing all of these calculations is computationally infeasible to implement in real-world applications, because the main control center executes all of these computations, takes a significant amount of time to do so. So to overcome this problem, the market-based algorithms or the decentralized approach have been proposed in the literature. Market-based approach or the market-based algorithm is a decentralized approach. So the decentralized approach converge way faster than the centralized algorithms to a certain solution. And the market-based algorithm imitates an auction procedure which includes bidders and auctioneers in the system. So the auctioneers announce the tasks they found in the system, and the bidders bid on the tasks. And the highest bid wins the auction, so the highest bid assigns the tasks. But as a major drawback of this approach too, it limits to reach a consensus, because the decentralized algorithms must require agents to reach a consensus due to the lack of the main control center which knows every possible information. And the agents must communicate with themselves in order to route the whole fleet. So it has a high chance, or these types of algorithms have a high chance to fall into local optimum rather than achieving a global optimum. And what we've done in our algorithm was proposing a novel approach for this task assignment procedure. It can make, or it can be it can do the two key differences, unlike the conventional algorithms that have been mentioned. So the first one is the market-based mechanism. The proposed algorithm uses the market-based approach as a primary mechanism to assign tasks to agents. But unlike the conventional market-based approach, it defines a certain threshold levels to each agents, which can be stimulated, which can be awakened by a certain stimulus. So by doing that, and also the auctioneers can bid the tasks too. So auctioneer starts an auction. Bidders bid on the tasks they want to assign, which participate in tasks, and the auctioneer's bid to the task is considered as a base bid value. So if one of the or any of the agents in the auction tries to bid lower than the auctioneer's tasks, then the agent won't bid at all. So this feature could reduce the message counts drastically. As a second key difference of unlike conventional algorithms is the multiple task assignments. Conventional algorithms are incapable of producing a certain solution in multiple task assignments. They're capable of producing a single task assignments, which one-to-one assignments are present. So in our algorithm, there is also can be done in multiple task assignments, which multiple agent required tasks can be included into the system. And in addition of these algorithms, there is also the 6-12 quadrilateral model has been developed in MATLAB in Simulink to test the algorithm's effectiveness and the performance. In figure 1, or in the left figure, we can see the MATLAB model, and in figure 2, certain inputs that have been given in XYZ axis, and the outputs as can be seen in figure 2. So the quadrilateral performance can be shown in here. And the results. The several scenarios have been conducted to measure the algorithm's performance and test the algorithm's effectiveness. So the first table, or figure 3, shows or demonstrates the payoff comparison. And the figure 4 demonstrates the message count comparison. If we can look at these tables carefully, we can see that in small scale applications, the Hungarian algorithm produces more optimal results and shows supremacy other than our algorithms. But in medium and large scale applications, it can be clearly seen that our algorithm shows dominance over the other algorithms. And also in multiple task assignments, which the agents and tasks numbers are unequal, the conventional algorithms are incapable of producing a solution. And in figure 4, the message count comparison can be shown, can be seen. In proposed algorithm, due to the proposed algorithm's decentralized fashion, it throws message a lot, but again, nevertheless, the message counts are lesser lesser than the market-based algorithm. But of course, in the Hungarian algorithm, the message counts are definable or just exact. So the discussion is the proposed algorithm combines the advantages of the conventional algorithms. So the multiple task assignment and the threshold-based approach are key differences that have been done in this algorithm. So and As can be seen in the tables, the proposed algorithm shows dominance in medium and large scale applications. So in conclusion, in this paper, we have developed an algorithm which solves the task assignment procedure by combining the conventional algorithm's advantage in a single framework and use it to assign tasks to agents. In future works, yes, it can be highly used in many fields, especially or significantly in military fields, which the usage or the utilization of the robust algorithms is highly requested. So thank you for listening to me. I hope this paper contributes to science and the related fields.
Thank you very much.
Thank you.
Do you have any question? May I ask a question?
Of course.
As you know, there are different search algorithms, especially for example, travel salesman,
Yes.
or the algorithm, and algorithm, etc. Do you have? Did you make any comparison between? This is only presentation and conference. There is no problem. But I want to know that. Did you make a comparison between the other search algorithms, maybe genetic algorithms, and etc.?
We didn't use genetic algorithms, but we submitted another paper in ICCONF conference, which is about the game theory-based decentralized algorithm for the multitask allocation, and we used here a traveler sales problem, and we implemented in our algorithm. So in this paper, the agents execute the tasks sequentially. So the set of tasks assigned the agents, and the agents found an optimal and shortest path by solving the ant colony optimization algorithm. So the traveler sales problem, but the traveler sales problem without returning an initial point.
Yeah, sure.
So it just ends in the final point. Yes, we've implemented in that in ICCONF and submitted our paper. So
Congrats.
Thank you.
Congratulations. Thank you very much. I guess this is your attending
yes.
participation certificate.
Yes.
Thank you very much.
Thank you.
Another one is Mamadou Volker Yazgo.